Okay, well, let's get started with the intros and we'll get going. So thanks. Welcome back, everybody. Our final panel on the day is on 120 volt heat pump water heaters. Very exciting technology. We've heard a couple panelists talk about it and mention it throughout the day. So here we're going to do our final panel. Will be a deep dive onto 120 volt. Before we kick it off, one last thank you for San Diego Learn for sponsoring this session as well. San Diego Learn has sponsored many of the sessions today, and they offer these free energy efficiency and electrification webinars. Check them out at sandiegolaearn.com. Thank you to San Diego Learn. So the session today, it will be moderated by Mischa Egolf. Mischa is a technical associate and part of NBI's building innovation team. She applies her engineering background to conduct data analysis, create data visualizations, and complete technical research for NBI projects and initiatives. And joining Mischa are John Koliner from Slipstream, Kevin Clark from Rheem, Dan Capelle from GE, and Tristan Dennis, and Mischa will introduce them all more fully. So thanks all for being here with us. And Mischa, I'll turn it over to you.
Great. Thanks, Joe. And thanks everyone for being here at the end of the day to learn about 120 volt heat pump water heaters. I am going to just give a super quick intro. I want to give most of the time to our excellent panelists. But as Joe mentioned, we've talked a little bit about 120 volt heat pump water heaters today. But for those who need a little bit of an intro, we've got 240 volt and 120 volt. So when do you want to do 120 volt? If your current water heater is electric, we're going to recommend that you do a straight swap to 240 volt. I also want to give a shout out to Joe for these great slides through Electrify Now. If your current water heater is gas, you can either go with a 240 volt, which typically is going to require a new circuit and some electrical work, or you can use an existing circuit with a 120 volt. So just want to kind of level set that that's really the market that this product is kind of thrives in, is designed for. And there are some key differences, just to, again, kind of level set as we hear from the panelists today. The 120 volt equipment is a 15 amp meant to be on a shared or dedicated circuit versus the 240 volt that requires 30 amp and a dedicated circuit. One of the benefits of 120 volt heat pump water heaters is that they can use existing wiring that you have. They have a slightly lower UEF than some of the 240 volt models, but not by a lot, and still a lot better than electric resistance. And they also have a slightly lower first hour rating and recovery rate. So that's something to keep in mind when you're selecting between the two. And so with that first hour rating is that recovery of 12 gallons per hour on average versus 27. However, 120 volt models have this mixing valve that can increase the capacity. So all of that going through very quickly. I'm sure there's a lot more nuances that the panelists could definitely chime in here. But the bottom line is the 240 volt heat pump water heaters are an excellent choice for replacing existing electric water heaters. And if you're able to replace a gas water heater without huge wiring upgrades, any sort of like circuit upgrades or anything, the electrical work not being super costly, then it's great to go with the 240 volt because you do get that higher first hour rating and recovery speed. Even still, it's good to size up a little bit if you're a heavy hot water user. Whereas the 120 volt units are best for gas water heater replacements where the electrification kind of upgrades are going to be really costly. And there are some caveats in terms of where 120 volt is going to do best. It's recommended for areas with higher inlet water temperatures. And you also want to definitely size up if you're a high hot water user. And I know John is going to talk a little bit about their field study in the Midwest, which kind of relates to these water temperatures. So excited to hear about that. So for those of you who may not have been following the history of 120 volt heat pump water heaters super closely, this is a really new technology. I just shared all of that great information, all those technical specs, and that basically happened in 6 years. In 2018, there was a retrofit ready heat pump water heater summit where a bunch of really smart people came together and they said, we have this vision for this plug-in heat pump water heater, and it literally did not exist yet. And now here we are in 2024, and there are products on the market. We've had multiple field studies that show that it actually works. And a couple of things that have happened in between related to that is we did do a 120 volt heat pump water heater field study in California. That went from 2021. So right when the market was really, when the units were first really coming out, that was 32 sites. And then there was a follow-on study that we did at MBI that showed load shifting capability of equipment at those sites that participated in the initial study. And there's a couple more that are still ongoing, and we're going to hear about one today from John in the Midwest. And then there's also one going on in New Orleans through Pacific Northwest National Labs, or PNNL. So a lot of really cool stuff happening in a short amount of time. And I think that there's this big question with any sort of new equipment, right? Which is, does it actually work? And so what we saw, at least in our study, is for the most part, folks were really quite satisfied with this brand new technology. And I want to just highlight this one particular participant feedback we got about hot water satisfaction, because that's the big fear, right? Is it actually going to give us hot water? And what we found, at least in our California study, was the answer is yes. And so I think that the fact that we've been seeing that is a good testament to the growth we've been seeing of this equipment in the market. So that's a super quick intro. I'm going to stop talking because I want to make sure that our panelists have a chance to tell us about some more interesting facts about this equipment. And I'm going to hand it off first to Dan Capelle from GE, who's going to give us a little bit of history. And we're excited to have you with us, Dan.
Well, thank you. I'm going to try to share my screen here, so bear with me just a second. And quick question, can you see my screen okay?
We can see your slides. You just got to put it in presentation mode. We can see kind of the whole view.
How about that?
I'm still seeing the whole slide deck, but you know what? You can roll with it.
Let me try this one more way here. Does it do anything different yet?
Not yet.
Okay, well, let's just go on and move forward. How about that? And I will make this thing as large as I can. How about that?
That'll work.
All right. Well, thank you for having me on the panel today. So Dan Capelle, I'm the Director of Product Management here at GE Appliances for our water heating product line. I thought I'd start off today just kind of walking everybody kind of back through a little bit of history here. So about 4 years ago, we actually were the first manufacturer to have a 120 volt model on display out in California for part of a working demonstration. For those of you who know Craig Sy, that's Craig Sy standing in the background of that picture. He was the first one to demonstrate this with one of our previous GeoSpring heat pump water heaters. This unit, as you're seeing right here, is plugged into a shared 120 volt outlet. And Craig was able to demonstrate that you indeed can make hot water off 120 volts. What I wanted to do today, though, is I wanted to kind of share from a manufacturer's perspective, from a user experience specifically, kind of some concerns that we as a manufacturer really want to kind of keep aware of. Okay, the first is first hour rating, right? We all talk about first hour rating, but from a 120 volt perspective, there's a couple things you've got to keep in mind. It's the first hour rating number, but it's also the size of the tank, so the capacity of the tank itself. Okay, the chart you see on the far left hand side here, it's really a comparison of the natural gas size tanks versus 120 volt unitary style tanks that are out there in the market. As you can see, just from a tank capacity to keep up with the number of people in the home, you've really got to upsize the tank typically. So it's not just the tank capacity, but then it's the first hour rating. Some other things to kind of keep in mind is it's so important because you want to make sure you've got enough hot water available for the surges in the morning or surges in the evening. The other thing to keep in mind from a manufacturer is the physical size of products. So as you go up in size, you may be increasing the diameter by 2 to 4 inches. You may be increasing the overall height by 8 to 14 inches. And all these things come into play when we're talking about trying to move products in and out of homes that may have tight door openings or low ceilings. The second thing to keep in mind from a manufacturer perspective is the recovery rate, right? This is after the products are installed. This is what somebody has to live with on a daily basis. Okay, so as a reminder, right, people love gas water heaters because of the fact that they replenish water so quickly. So homes can actually downsize in the size, the capacity of the water heater because they replenish much quicker. So as we get into heat pump water heaters, the recovery rate can be anywhere from 3 to 6 times longer based on the fact if it's a 240 or 120 volts. So once again, proper sizing of these things is very important because at the end of the day, if it's undersized and underperforming and not hitting expectations, the industry and we as manufacturers will hear this day in and day out. The final thing I want to touch on here is the service side. So from an environmental perspective, we're going to have these units out there on the tank side of things. When we talk about like anode rods, elements, drain valves, any plumber could take care of that. But when we start looking at the heat pump system part, this is the part if it ever fails, right? If you don't have a product that's serviceable, well, then all of a sudden a plumber would have to come out there and replace the whole product. And that's not really a good situation because then that product will have to go into a landfill and be replaced with a brand new unit. Our approach on this is we thoroughly believe that these products need to be serviceable so that you can repair them, keep them going, and have a long life out of products. So I'd like to kind of introduce what we're getting ready to launch. So this is our 4th generation heat pump. So this is our GE Profile GeoSpring heat pump water heater. This water heater is going to be our best efficiency and performance of all the products that we've launched out there in these heat pump worlds. We're going to have this in 120 volt and 240 volt options. One of the great, interesting thing that we put in these products is an electronically controlled mixing valve. I've heard a lot of conversations today about the mixing valves, and we've actually got this technology embedded into the product straight from the factory. We've actually had that technology out there in standard electric products for about 5 years now, and so we've got a really well-designed product from the mixing valve perspective that works fantastic. Some of the other things that we've done on the product is we'll have a sensing anode rod as well as leak detection, really to make sure that the product is well protected and the homeowners get the right alerts if needed. The capacities we're going to have in this thing is a 40, 50, 65, and an 80-gallon capacity. And let's see here. Just going to play a quick video here to kind of show you what the product is. All right. One thing I do want to hit on that video is I've heard some other discussions today about using these products as thermal batteries, and with our integrated electronic control mixing valve that we've got in these products, we have a product that will be able to do that as well. So it's really a win-win from a utility company perspective too, because a utility company gets the advantage of a heat pump water heater to lower the overall energy consumption. But in addition to that, they now have the ability to take energy and dump it into a water heater and elevate the temperature of that tank ahead of time, so they can get ahead of any demand curves. The last page I'm going to show you here is just a quick overview of what we've got the control on our app. We use an app that's we do with the rest of our appliances. It's called GE Smart HQ. The advantage of this, it really gives homeowners the power of seeing what's going on in their water heater and the control of the water heater in the palm of their hand from their smartphone. So these are very advanced products, and so we firmly believe in giving people the ability to kind of watch what's going on and monitoring the product and scheduling the product if they want to make changes. And that is all that I've got to present today.
Awesome. Thank you so much, Dan. And sorry about your slides, but it was still great to see what you've got. And that's really exciting about the new product coming out. So next up, I'm excited to introduce Kevin Clark from Rheem. Kevin, take it away.
Awesome. It looks like our robots were holding hands there for a second. So happy heat pump water heater day. I know we're close to wrap up, so I will make this quick here. Hopefully everybody can see my screen. Get it in the presentation mode. How does that look for everybody?
Looks perfect. Thanks, Kevin.
Awesome. So again, Kevin Clark with Rheem. We've been talking about heat pump water heaters now for quite some time. We launched ours in 2009 as well. We're already on our 5.2 generation with the ProTerra refresh that's out in the market today. And with the 120 volts, we've been out in the market now for a couple of years. We were hoping to get out there a little bit earlier from that meeting in 2018 out in PG&E territory, but with supply chain and all that happy stuff that was going on at the end of COVID, we were delayed. But still, we've been out in the market now for over 2 years with a couple of different flavors of plug-in product. And really, I kind of want to take a step back on where this product is going to have some success. I know this graphic is a couple of years old now. But, really, we designed and launched this product for California. Realistically, with its fuel switching availabilities and policies and of course, incentivization, it's been, pretty successful in a lot of the programs, especially the tech program that has been going through in that state for a while. Again, this is a gas retrofit. So this is something that is meant to replace a gas water heater in certain conditions. And, again, if you look across where our heat pump water heater is really best suited, we still need a lot of help out there in getting some of these policies enacted for incentivizing fuel switching. So it's not available everywhere. Where it is a good spot for 120 volts to go in and decarbonize the grid. If the grid is pretty clean in the area, you can potentially save over a ton of carbon a year just by making this technology choice for the homeowner. So again, at Rheem, we're very focused on our sustainability mission. And this is something that we're kind of lining up with our 100-year birthday next year. So we want to have, zero landfill impacts. We want to reduce carbon by 50% in the products that we sell, as well as reduce our own internal carbon by 50%. So again, this is a product that really leans towards that sustainability goal. And if you look at overall the family of brands that Rheem has, especially when we're going into California, we can decarbonize your pool heater, with a heat pump pool heater. Decarbonize your water heater with 120 volts or 240 volt model. And then also your HVAC systems. So again, we can help decarbonize over 2/3 of the consumer power bill with Rheem products. So this is certainly a big mission that we have had for quite some time. If you look at just Rheem's investment in the products, we have 30 residential SKUs out there in each one of our brands. 120 volts having 10 of those. We have commercial central systems. So lots of focus and lots of attention has been paid towards heat pumps. So we're really looking forward to this transformation that's going on as we speak. So, really, why make that choice? With a 120 volt, it's not for everybody, but in most cases, it will be an easy transition. You don't need that electrician, which is another trade, coming in to do the 30 amp 240 volt run from the panel. That's even if the panel has enough capacity in there to provide that extra breaker. On top of that, makes it very easy. Solar installers can add this into their portfolio. It's something that will help the payback story of a solar installation by adding heat pump water heaters, going from a gas to this type of product. Again, they're spending about $30 a month on gas bills to power their gas water heater. And again, if they add a couple more panels to the proposition, it will 100% pay for that heat pump water heaters operations throughout the year. Again, we already talked about decarbonization. Mentioned we have two different flavors of heat pump water heaters. We have a dedicated circuit model that has a full ton compressor. So you're getting about 15,000 BTUs of recovery. We have those in the 40 and 50 gallon capacity. If you really looked at the building stock of California for the past 20 plus years, builders have been required to put that single plug in over by where the water heater is located for that future tankless or future condensing gas product. We're going to use that with the smaller form factors for that dedicated circuit product. It will recover that tank. You saw Dan's recovery chart there. It will recover that tank in about an hour's time. So it really does ramp up the recovery rates. And it's, again, in that smaller form factor. That way, no other retrofit has to be done in the garage in order to accommodate a plug-in heat pump water heater. Again, those can suit the needs for up to a family of 5. And, really, this is where training comes into play. This is where Rheem really shines. We train over 30,000 contractors a year on efficient products like heat pump water heaters. So, we certainly want them to have an honest conversation with homeowners. If they are a family that takes, back-to-back baths, that's probably not the right product for them. If they come home and say one person in the family is a mechanic and they do a deep fill on the hot cycle in their laundry machine, that's probably not the right solution for them either. So in most cases, it's the perfect solution, but again, it's not right for everybody. We just want to make sure we're offering the right application for for the homeowner. Again, the industry has really asked for that shared circuit design that can be plugged in anywhere. That's you see the bottom row of products there. 40 and 50 gallons were really designed for those ADUs in California, as well as multifamily applications. For single family, especially the ones that we're running in tech, we've been installing the 65 and 80 gallon capacities. Again, if you look at a day's worth of hot water, a typical average family of 4 is going to be in that 60 to 65 gallon range. So again, when you're sizing these things, you have a day's worth of hot water at any given time. It doesn't really matter if it's going to take a few hours to recover that tank or not, or sometimes up to 5+ hours if it's an 80 gallon. So that's what I had to share. I'm going to stop sharing the screen here, and we'll move it along.
Thanks so much, Kevin. That was great information. And 30,000 contractors a year. That's a lot. That's a lot of training. All right, I'm excited now to introduce Tristan Dennis from Barnett Plumbing, who's going to talk about some challenges and opportunities around the many installations of this equipment that they've been doing. So Tristan, take it away.
Thank you. All right, let me share my screen real quick. All right. Can everybody see all right?
Looks great.
Great. All right. Well, hey everyone. My name's Tristan. I'm the project manager at Barnett Plumbing and Water Heaters. Barnett's a plumbing company that specializes in water heaters. We're located in the city of Livermore in the San Francisco Bay Area, and we've been installing heat pump water heaters for a few years now. Just this last year, we installed over 500 heat pump water heaters, many of which were these 120 volt models. And so, lucky for us, we've had a lot of experience with this technology out in the field. I want to start by talking about some of the key advantages we found with these water heaters as installers. First and foremost, the biggest advantage is definitely that there's little to no electrical work needed because of being able just to plug into an outlet, especially when it comes to the split circuit compatible models. It's great for homes that already have maxed out electric panels, or even for homes where the homeowners are planning to electrify more appliances so that way we're not taking up space on it. And that way, homeowners don't need to have large budget set aside for a electric panel upgrade. Again, that also gets rid of the need for electric subcontractors or the need for plumbers to learn electrical work. And so it makes the market much more accessible for plumbing contractors to be able to enter into. They're also quicker to install because there is no need to wait for a dedicated line to be installed by an electrician. That means that plumbing contractors can offer same day or next day installation and still do that fuel switch for the homeowner. And then they're still going to get that guaranteed efficiency of 3 to 5 times boost over other water heater types. This also, opens the market for homeowners who are DIYers. Handy homeowners can explore electrifying their water heater without the need for electrical contracting knowledge or knowing a contractor themselves. And so it just opens the path for a lot more homes to be able to access the heat pump water heating market. So things to consider when looking into installing 120 volt heat pump water heaters, first and foremost are just building department concerns. So we have found that there are quite a few building departments where they are still inexperienced with heat pump technology. Lucky for us in the Bay Area, there are certain cities that have dedicated their time and resources to training their building officials. But we've seen that it's more geared towards the 240 volt hybrid heat pump water heaters. And so we just have realized that we need to do a bit more explaining when it comes to how the 120 volts work, and a bit more convincing that, the homeowner will still get the hot water they need. So, we've had inspectors who have doubt in their ability to deliver, but we've always been able to overcome those concerns. Another thing to consider is the breaker size. So, when you're plugging into an existing outlet, we just need to make sure that we're installing them on the correct breaker size for the manufacturer. So, for instance, the Rheem plug-in units, their nameplate states that they need a 15 amp maximum circuit. So we just make sure that either the outlet we're plugging into is already on a 15 amp breaker, or we're prepared to downsize the breaker if needed. And then also making sure to just be aware that it has a much slower recovery rate. That's fairly easy to overcome. We always upsize. At Barnett, we recommend upsizing 2 sizes. And then we also install a thermostatic mixing valve. It's kind of more of a be more safe than sorry policy, because we do know certain homeowners have upsized only 1 size and been fine, but we just prefer to recommend sizing up 2 sizes just to be sure that the homeowners will always have enough hot water. And because of the upsizing, you just want to make sure that wherever you're installing the heat pump water heater, there's enough space for the extra gallons. We have found that, if the current space for the water heater doesn't have enough space to upsize, that there's almost always an easy relocation option. So we do offer that to our customers as well. just to make sure that, anybody who wants to electrify is able to. And so key takeaways from the field, first and foremost, they really do work. We've installed a lot of them, and our homeowners are super happy with them. They've 100% lowered their electricity bills. They haven't had issues with hot water. And, like I said, these 120 volt plug-in models give installers access to a much larger market, since they don't need to know an electrical contractor or do any electrical work themselves. Plumbing contractors can be much more confident in recommending a heat pump water heater this way. Homeowners don't need to worry about doing any panel upgrades, and they can still get same-day replacement. So contractors face a lot less barriers, since homeowners won't need to wait to be able to get hot water again, and they won't have that additional work done on their home. It is important just to be aware of the local building codes. I always recommend reaching out to the local building department before installing a 120 volt or a heat pump water heater in general, just to see if there's any concerns that they might have ahead of time, so that you can get ahead of those and hopefully educate the building department a bit on how the technology works. And then also just be sure that space you're installing it in can handle the new water heater size. So wasn't a lot, but thank you so much for having us on the Heat Pump Water Heater Day panel. I hope this information gave you guys a bit of insight into our experience with the 120 volt models, help give you a bit more confidence in them. And, Barnett's always happy to share our experiences and help out whenever we can.
Thanks so much, Tristan. That was really insightful. It's good to hear that folks are happy. I definitely
really
have some follow-up questions for you when we get to the Q&A.
Yeah, great. No, that's perfect.
All right, next up, last but not least, we have John Koliner, who's going to talk about Slipstream's experience with heat pump water heaters in the Midwest and the field study that they've got going on. So excited to hear about that. John, I can already see your slides. You're ready to go. Hand it off to you.
Okay, yeah, I'm bringing up, I think besides Alexi, I'm bringing up the rear on this entire heat pump water heater day. So it's 4 p.m. at the best of times for folks who are attending. I hope I keep your attention. So I'm John Koliner. I'm a director of research at Slipstream. This study of heat pump water heaters in the Midwest was, not entirely mine, even though I'm the one speaking to you. Our lead analyst, Danny Ball, PM Robert Klein, and then not listed here is Sarah Wells, who did the satisfaction survey work, as well as our friends at NBI are partnered with us on this study. And, it's conducted on behalf of 4 funders in the Midwest, which is, quite a lot of interest from utilities and state organizations. Focus on Energy, ComEd, Consumers Energy, and Xcel Energy were both gracious enough to provide funding. So data collection is a wrap. We've installed at 27 sites across the Midwest. We monitored for 9 months, including the coldest groundwater months. And now we are pulling back equipment. I was removing equipment in the field last Friday. Danny's going out next week. And we should have everything pulled out, I think, by the end of November, with full results due at the end of 2024. As part of this work, we had long form interviews with installers. We also did 4 surveys, satisfaction surveys on their prior water heater, then a survey 1 month in, a survey at the end of winter, and a survey at the end of summer, which all the results have not come back for yet, but we're excited to see what people think on that one. We had 3 participating manufacturers with 4 types of units deployed. We deployed those, some of the Rheem dedicated circuit models that Kevin mentioned, as well as shared circuit models. We had A.O. Smith models, 10 of those in the study, and 1 Nile split system in the study. Here's a picture of all the many basements that we have visited across this work. Okay, so on to results. So we've been monitoring a variety of metrics from the heat pumps. We have the water temperatures, we've got the flow, we've got power consumption. We've got kind of everything we need to calculate COP and also to see whether folks are experiencing hot water runouts or whether the total energy consumption of the units and all the things we would want to know, as well as temperatures in the room and humidity in the room. Here's a picture of the energy consumption from the dedicated circuit models versus shared circuit models, just to show you the type of data we're collecting live. And you can see that shared circuit model is, it's about a ton of heat, or about a third ton of heating, versus the dedicated circuit model, which is running at over 10 amps and is putting in about 1 whole ton of heating, which does translate to 1 whole ton of cooling in the room that it's located in. Okay, so I wanted, the study data collection is concluded. I wanted to do a new results slide so that everybody could see something kind of interesting and exciting. This is something that the manufacturers have called out. What is the impact in these northern climates of the cold groundwater? Should we be recommending them? Should we not? So the graph on the right, first of all, has groundwater temperature on the x-axis. So that's the water coming into the water heater, going from pretty cold down at 40 degrees up to 70 degrees, where it's nice and, pretty lukewarm. That y-axis is minutes powered on per gallon consumed. So this is daily data. And what we're looking at is, in a day, how many gallons are consumed of hot water and how long does the unit run for? And that's a nice thing to look at because it translates, or it mostly translates to, the reported recovery times from manufacturers. So up at 70 degrees, we have an average line here, and the units are getting about 6 minutes per gallon. So it takes about 6 minutes to heat up 1 gallon of water, which is 10 gallons an hour, which lines up pretty well with what the what is reported in the spec sheets. I will note that there's dedicated circuit models down below that recover much faster. That's where you can see that kind of different band. But when you get down to 40 degrees, now you're looking at something like 10 minutes per gallon, which is about 6 gallons per hour, which is slower and potentially noticeably slower. So it is true that the units recover slower when colder groundwater is coming in. It just takes more time to heat that water all the way up to temp. The thing to be cognizant about with colder groundwater is that high use and clustered use can lead to runouts. And specifically, you need to think about use across kind of more than that first hour rating, across like 3-hour spans. So a key question that we suggest asking to customers, especially in the Midwest, who are looking to install these 120 volt heat pump water heaters is, how frequently did you run out of hot water, or have you run out of hot water in the past? And if they say more than like once a year, then I would shy away from recommending these units, because that long recovery time is going to mean that if they're running it out routinely, they're going to, see hours where it's still cold afterwards. That being said, most customers did not experience runouts in our study. They didn't notice them. I mean, we have very fine-tuned measurements of like, okay, the temperature dipped by 5 degrees in the outgoing hot water, but most people were totally fine, totally happy with their units. And that's kind of shown on this slide here. We don't have the summer results yet, but they look pretty good so far. Customers are mostly happy. That's over 75% are in the, highly or extremely satisfied. And then, 20-ish% are neutral. The summer results, I think, are going to look even better than this. We've seen good results coming in so far, and that's because, during the summer, it's heating water faster, and B, it's providing additional cooling and dehumidification, both of which are considered benefits in the summer. We didn't notice any real complaints about noise. There was no dissatisfaction with changes in humidity, and there were fairly minimal comments on space cooling. Some customers noticed it and would prefer it wasn't as cool, but it wasn't significantly impacting their satisfaction. The biggest issue, which is shown in the poll quotes, is if a customer did have that clustered use, multiple showers in a row, where they were not necessarily holding themselves to a 5 to 7 minute shower, they could see runouts, and that is the biggest cause for dissatisfaction. But we just didn't see much of it. I think only 3 sites reported that was going on. So, big takeaways. I say put them in the warehouse, have them available for fuel switching, even in the Midwest. The key caveats are they're the right unit if cost is a constraint. There's a place to plug it in, for example, from a power vented gas water heater that's in place currently. The customer does not report running out of hot water previously, and there are 4 or less occupants. Definitely upsize, and I would say those constraints, that's like not very constraining. That applies actually to a lot of households. You would find there's a lot in that bucket of 4 or less occupants who would prefer to spend less and have a place to plug it in. And finally, installer education is very important. Installers need to come with a condensate pump. That's true of all heat pump water heaters, not just the 120 volt units. And they need to be well educated on the ducting and make sure that they have ducting materials available. They should have 1 unit's worth of the ducting, the adapter for ducting before they go to any site. That's what I have.
Awesome.
Thanks.
Thank you so much, John. Very cool. Can I ask a quick question before the Q&A? When do you expect the results of this study will be available, like in a report?
Our report is due to our collaborating funders at the end of the year. It will likely not be publicly released then, but so sometime in the first quarter of 2025, I would imagine folks will be able to look at it. And
Awesome.
I'm hoping to present at the Hot Water Forum on the contents of that report. So
perfect. Well, everyone give our presenters a virtual round of applause. Thank you all so much, and feel free to come back on camera. We've got a few minutes for Q&A, and there's already a couple of questions that have come in. For anyone in the audience, yes, thank you for the hand clapping emojis. We love that. For those in the audience, you can use the Q&A function, or you can chat to send a question in. We do prefer the Q&A, especially now that we have all the clapping hands. Don't want to lose any questions. So the first question that came in that I think is a pretty easy one, I'll loft it to Kevin. Are these units available in the Midwest for customers?
They would be special order in the Midwest. We'd really want them to, again, get that training that John was mentioning, just so they are aware of, again, to, set it up correctly. We want to have a good experience for, these consumers that are making this type of adoption. So.
Perfect. Thanks. All right. Next question. Let's go ahead and go with this question from Joe about to John. Why were customers dissatisfied with their prior water heater, their gas water heater? Did you track if they were old or if there were other reasons?
Actually, that's a good question. We should dig in on that. I am not 100% sure. Some of them I think probably had a substantial amount of like buildup inside of them, and they also maybe were not tuned correctly in terms of temperature, and customers reported, insufficient hot water. And so some of it is like maybe that when the plumber came and they, reset everything, it just made the experience better getting a new water heater versus an older water heater. Got
it. All right, question next
Wait,
for
the-
Tristan. Oh, yeah.
They were all old, actually. For the study, we did, as part of our screening criteria, ensure that we were installing them where folks had older water heaters. And that was kind of a customer satisfaction insurance policy of, we wanted to replace water heaters that should be replaced anyway, not be replacing a new water heater. And then somebody would be, if they ended up upset, say, why did you take away my brand new water heater? So.
Got it. Yeah, that totally makes sense. Thanks for that ad, John. All right, next question I think is for Tristan. I've got 3 thumbs up in the Q&A, so lots of people want to know what barriers to the sale are you encountering in the field with customers needing to replace a water heater?
Yeah, so when it comes to 120 volts specifically, it would be just customers not being sure that they're going to work because of that low recovery rate. We're lucky because we've installed so many at this point. We actually the other day had one customer call another to tell them how well it worked. So it's really good to have that data on our end. And then another barrier that is actually solved by the 120 volts would be the timeline issue of, hey, I want to electrify my water heater. My water heater just died. I don't want to wait for an electrician to do this work. What can be done? And so we can offer a solution that day a lot of the time. So
that's super helpful. And I guess I'm going to just pop in with a quick follow-on question. You mentioned that you had a lot of issues with building departments, but you've been able to kind of navigate through those. Do you have anything you can share in terms of strategies for what you found to work best to resolve those concerns?
yeah, it's actually similar to what we would do with customers who aren't certain. Either we'll have building officials reach out to other building departments where we've done more of these water heaters and ask them how they've gone about the inspection process, or reach out to homeowners if, for instance, there's one specific inspector that's concerned, but we've already installed these units in their jurisdiction. We'll have them reach out to homeowners to see how they've worked. Beyond that, we'll just share as much data and manufacturer information as needed to overcome any concerns they have.
Yeah, Good Party has been a great partner on bringing some of those concerns to us to make adjustments. You'd like the 15 amp. It was, it's just a quick little edit, 15 amp minimum,
Right.
Breaker size. So, good feedback for us, and that way we can get back out to the market to make sure some of these inspectors are okaying these projects.
Yeah, and Kevin brings up a great point. Like having the manufacturers help out has made the building officials will listen to manufacturers much more readily than they will contractors. And so if you have a relationship with your either sales rep or the manufacturer, that has been a big help.
Yes, I love the spirit of collaboration. Everybody working together, pulling the same direction. That's great. Thanks for that ad, Kevin. I noticed that there's a question that popped up in the chat, and since Dan hasn't been put on the hot seat yet, Dan, I'm gonna send this one to you. Why stick with the GeoSpring name for Gen 4 since it's been almost 10 years after GE exited the market?
Well, I'll tell you, it was such a good name that we still have a lot of people asking for that as replacements. And so, since we've been out of this for about 10 years, it's products are at the end of the life cycle, and believe it or not, we have a lot of people continue to ask us for that same product. So it's a great reference point for those who have them in their homes already. A good question, though.
Soaking monkeys, I love it.
All right. Let's go back to John. We've got a question for you. In the homes that got 120 volt heat pump water heaters, did you try to assess or track what would be involved in installing a 240 volt heat pump water heater instead?
Yeah, and we did see a few homes where it was pretty much equivalent. Like they had enough space in the panel even though we tried to screen for outlet distance, sometimes, you just miss by a little bit and they'd need to run a circuit. And so in those cases, it was like, if there's space available, you're already running a circuit, that's the right time for a 240 volt. And we actually did find maybe 2 homes where they had a 240 volt circuit already hiding in the wall behind the water heater, because at some point the house had switched to gas from an electric water heater. So that's why I make the recommendation that, they should be on the truck, or they should be in the warehouse. They should be, available to the installers so that the installers can use them when they're appropriate. Our study was not designed to find the exact appropriate use case from not a 240 volt perspective. But if it's the same in terms of effort, definitely do a 240 volt. But the 120 is, if it's going to cost more and it's the right installation parameters in terms of occupancy and use.
Got it. Good to know. And actually, you touched on something that I think would be a great question for both Dan and Kevin. Question from Tom Cabot. Is there a way to get these units approved with longer power cords? I've heard many folks don't have an outlet within 9 feet reach of cord.
Yeah, well, there's there are UL regulations we all have to follow as manufacturers, which kind of limit the length of cords that can be pre-installed, factory installed into products, right? I can speak for ours that you'll have the ability as an installer to rewire if you need to rewire, but that's kind of the limiting factor that really drives a lot of what we can pre-install in the factory. Kevin, anything to add from your side?
No, pretty similar. I think we put a 9 or 10 foot cord on, so it's if you look at a garage, which is usually 10 by 20, normally we're within a plug if there's a plug there.
And I would just note, in that circuit extension discussion, it is easier to take an existing 120 volt circuit with an outlet and extend that than it is, for a shared circuit model, than it is to run a circuit entirely from the panel in many cases. So there is still some benefit, but if you can't solve the cord issue, you can't solve the cord issue.
Good to know. I think at one point I heard someone suggesting a 20-foot cord. It starts to get a little scary.
That would be nice. That would be nice for sure.
All right, Tristan, I'm going to go back to you. I think this is a follow-on question to something you had answered earlier, so maybe your answer would be the same. But in terms of customer barriers, do you have what barriers related to replacing an electric water heater? Do you have situations where people have electric resistance and they want to stay with electric resistance? And is there anything different in terms of your approach in that situation?
Well, if they have an electric resistance, I heard one of the other panelists say this earlier, we would just suggest sticking with the 240 volts since you have the wiring right there. Actually, if a homeowner has an electric water heater, it makes it much easier to sell a heat pump, just because they don't have to do any extra electrical work, no changes to their panel, and they get all the efficiency benefits. And so it's actually a great option for homeowners with an electric resistance water heater.
Yeah, and because it has 2 methods of recovery, they typically have a higher first hour rating as well.
Yeah.
The pump and the element will recover at the same time if necessary.
Mm-hmm.
Perfect. That's a great distinction. Okay, so let's see here. We've got so many good questions coming in. This looks like a question for you, Kevin, maybe. Rheem recommended setting mode to energy saver for best efficiency. Why not the heat pump mode? And then a second follow-on question, which could go to really anyone on the panel. If you have a mixing valve, is it better to set water heater to 140 degrees and mixing valve to 120 degrees? So it sounds like, what setting do you recommend? So this could go to both Dan and Kevin. And if you have a mixing valve, what do you recommend in terms of temperature set points?
But I mean, that gets really into the DOE testing protocols that manufacturers build towards and build controls around. And that sometimes doesn't necessarily align with real world efficiencies. So yeah, energy saver mode in the DOE testing procedure is going to be more efficient than putting in heat pump only mode. So that's just a controls thing. If you're really looking for real world higher efficiency, it's going to be that heat pump only mode, because the element will not kick on, which again has a COP of about 1 as opposed to 4/4. So when you look at a lot of the heat pump water heaters that were installed in California under the tech program, it was also scheduled for time of use rates. So most of the day is under some sort of control, from that 9 a.m. to 9 p.m. period. So they're typically running as 120 volt products in that state, and we don't see too many complaints on hot water delivery. As far as the set point temperature, again, that is just a level of energy storage. If you're running out of hot water, raise that set point temperature up a little bit if you have that mixing valve that's already installed. If you're still running out of hot water and you're in a 240 volt model, there's different modes to go into, including energy saver, which is our hybrid mode, as well as the high demand mode, which just turns the element on a little bit sooner. So it's not like your typical water heater where if you run out of hot water, the only option is to turn the temperature up.
Yeah, and I'll address a little bit on our mixing valve approach. Is we've turned it into a feature on the product where you can either engage it and have it on, or you can turn it off if you don't need it. And there's preset points on it, so it's 3 settings. So if it's off, then the tank temperature matches the controller set point, or you can elevate it up to an extra high setting, which will give you like 60% more capacity in that water heater. And then even though the tank itself is hot, the outlet temperature matches whatever temperature set point the user has put on the control panel.
And I'll just add, the A.O. Smith units have an integrated mixing valve, and they don't report the tank temp, but they do dial up the tank temp on the inside. So what goes through the UI is your delivery temp, and then the water heater decides its tank temp.
I think somebody had mentioned, I don't know if it was a session or earlier one, on UEF and 120 volts, being a little bit lower. Again, a little bit of that is within testing for the 120 volts. We want to deliver enough hot water. So we test those at a higher set point temperature. And that way we can have a higher first hour rating, because a lot of these programs utilize the universal plumbing code for first hour ratings. For available products. So that's why you see a little dip in UEF reporting. Ours for the 65 and 80 are going to be up over that 3.3 threshold. Our dedicated circuit models are going to be at that 3 level. So it's just, again, real world efficiency. It's going to be, the most efficient product out there because it doesn't have a backup element.
Yeah, and I actually see in the chat Amelie, who was one of our panelists in the last session, which was about load shifting, mentioned if you have your heat pump water heater set at 140, then it makes it difficult to do the advanced load up if you're doing a load shifting protocol. So I don't know if there's anything you, Dan or Kevin, want to comment about that, but I did want to just call out that aspect of it too, since I know that's kind of an emerging area of interest.
Yeah, just real quick on ours is we have the ability to go higher than that. So if it's a load shifting need that they want to do, we got the capability and flexibility with the product to really address that and allow utility control on it, to dump excess energy into the product remotely. So.
Got it. Good to know. So I know we are getting close on time. I have one more question from the Q&A, and then we'll have a final question for everyone. So I think maybe for John and Tristan, since you haven't been on the hot seat in a minute, is hard water an issue for heat pump water heaters? And is this a question you get from folks? Or in the field study instance in the Midwest, is that something that you cared about at all?
I can jump in first. I mean, hard water it's just as much of an issue as it is for any other water heater. We haven't experienced anything specific when it comes to heat pump water heaters. We still recommend to flush it at least once a year. And then beyond that, I mean, there's not any additional maintenance you need to do, depending on your water hardness.
Yeah, that's great. I don't have anything to add to that.
Fair enough. Well said, Tristan. Okay, so Joe put a question in the chat, which will be our kind of final question for the day. To everyone, what percentage of the market do you think eventually will install 120-volt heat pump water heaters? And we'll just say you can pick the region of your choice and you can just guess at it. What would be your dream or your guess? You can be realistic or not.
Who are you directing to?
Everyone. Kevin, you go first since you spoke up first.
All right, so you know that is kind of very wildly, right? So again, we're talking about a retrofit product that is really relying upon rebates. You know, it already qualifies for the tax credit, which is great, but stacking it along with local utility rebates is also going to be very important. Or, you know, again, if you look at gas usage throughout the country, that's the market for fuel switching for this type of product. And then you have new construction. You know, you see a lot of new codes coming out that are really requiring heat pump water heaters, which then steers it towards a 240-volt model as opposed to a 120-volt model. So it is a really complex question to answer. It's one of those things that's probably not going to play, you know, on a majority of the scale by any means.
Yeah, very well spoken there, Kevin. But yeah, it's you know, it's going to be a niche kind of product, right? Addressing certain specific needs. And as a manufacturer, we would probably recommend the 240 all day long over 120 if that fits the installation side, just because of recovery and performance, those things.
Yeah, I'll piggyback off what Dan said. We would also, as installers, recommend the 240s if it's an option. You know, in the Bay Area, we do have a lot of older homes that are, you know, 100 amp panels. So it's given us an opportunity to still offer electrification. Just to steal one of Joe's numbers, I'd say we're probably looking at currently about 20% of the heat pumps we install are plug-ins. Just because they actually work and they're great options, we can still offer them. But, you know, when there's the opportunity to do the 240, we will.
Yeah, I won't give a number, but in the Midwest, there's a lot of natural gas already. There are fuel switching regulations and goals, which some of them are, you know, pushing things aggressively, and some are less aggressive or dicey at the moment in the Midwest. And household sizes are shrinking over time, so it's not a bad option. And could be, you know, a good product to address the market.
All right. Nobody wants to put bets down. I guess I'll take it. No numbers. That's all right. All right. I know that our time is up. I'm going to hand it back over to Joe. But once again, thank you all so much for sharing the information and answering all the questions today. And thank you to everyone who submitted a question. I'm sorry we didn't get to them all. We did our best. So, Joe, I'll hand it back off to you.
Awesome. Thanks,